Ever glance at those colorful tubes during a blood test and wonder what secrets they hold?
Hmm.
We see them all the time,
Yeah.
but few of us truly understand the science behind those hues.
Right.
So today, we're taking a deep dive into the world of laboratory medicine
Okay.
to explore how these seemingly simple tubes revolutionized healthcare.
It's a fascinating journey, really, from basic diagnostics to groundbreaking research.
Yeah.
These tubes are the unsung heroes of modern medicine.
Okay, so let's start with the basics. Why are these tubes even necessary?
Yeah.
Can't we just analyze blood?
You'd think so, but blood is surprisingly fickle.
Yeah.
Outside the body, it's prone to clotting, degradation,
Right.
and all sorts of changes that can skew results.
So these tubes act like tiny time capsules, preserving the blood in its most pristine state.
Precisely. Each tube is carefully designed with specific additives that target different components of blood,
Okay.
essentially hitting pause on certain processes so we can get an accurate picture of what's going on inside the body.
That makes sense. It's like taking a snapshot of your health at that exact moment.
Right.
So how did we even get to this point? Were blood tests always this sophisticated?
Not even close. Imagine the early days of blood research, before standardized tubes.
Oh, wow.
Scientists were grappling with the inherent instability of blood, trying to understand fundamental processes like coagulation,
Yeah.
but their efforts were often hampered by the limitations of the tools available.
That must have been incredibly frustrating. I mean, how can you study something that's constantly changing under your nose?
It was a major hurdle. But this challenge ultimately spurred innovation. Scientists realized that to truly unlock the secrets of blood,
Yeah.
they needed a way to control its environment, to preserve it in a way that allowed for accurate and repeatable measurements.
And that's where these color-coded tubes come in, right?
Exactly.
Each color representing a specific recipe for preserving and analyzing blood.
It was a stroke of genius, really.
Yeah.
By standardizing the tubes and their additives, scientists created a universal language for blood testing, allowing for more reliable results, consistent data,
Yeah.
and ultimately a deeper understanding of human health.
It's amazing how something so seemingly simple could have such a profound impact. Okay, so let's talk colors.
Sure.
I'm ready to decode this laboratory rainbow. Where do we start?
We'll begin with the pale blue tube, a rather unassuming color, but don't let that fool you.
Okay.
It's the guardian of coagulation, a key player in understanding how our blood clots.
Coagulation.
Yeah.
So that's the process that stops us from bleeding out, right?
Absolutely. Pretty important stuff.
And the pale blue tube, with its special ingredient sodium citrate,
Okay.
allows us to measure this process with incredible precision.
Uh-huh.
Sodium citrate binds calcium ions, which are essential for the clotting cascade,
Right.
effectively hitting the pause button on that process.
So it's like taking a freeze frame of that intricate clotting cascade.
Precisely. This allows us to perform tests like the prothrombin time, PT,
Mm-hmm.
and partial thromboplastin time, PTT.
Which measure how quickly a patient's blood clots.
And why is that information so important?
It has a wide range of applications.
Oh.
For example, if you're about to have surgery,
Yep.
doctors need to know how well your blood clots to prevent excessive bleeding.
Right.
Similarly, if you're on blood thinners, these tests help ensure you're getting the right dosage to prevent dangerous clots.
It's like finding that perfect balance, not too much clotting, not too little.
Exactly. But the pale blue tube's impact goes beyond individual patients.
Oh.
It revolutionized research on heart disease.
Hmm.
Before standardized coagulation testing, large-scale studies struggled to compare data because there wasn't a consistent way to measure clotting. The pale blue tube changed that, leading to groundbreaking discoveries about the link between coagulation and cardiovascular health.
So this little tube helped us understand how to better prevent and treat heart disease.
Precisely. It paved the way for new treatments, like anti-clotting medications, which have saved countless lives. But its significance doesn't stop there. The pale blue tube has also shed light on other conditions that affect coagulation, like liver disorders, kidney diseases, and even autoimmune diseases.
Wow. It's incredible how one tube can impact so many areas of medicine.
Yeah.
Okay, so we've paused the clotting cascade, but what if we want to let nature run its course?
That's where the red tube comes in.
Okay.
This tube contains a clot activator, essentially encouraging the blood to do what it does naturally form a clot.
So we're letting nature take the wheel in the red tube.
Exactly. And after the clot forms and the sample is spun down in a centrifuge, we're left with a clear golden fluid called serum.
Serum.
Yeah.
Sounds familiar. Isn't that what they used to test for all sorts of things?
You're right. Serum is like a liquid window into the body's chemistry. It contains electrolytes, lipids, hormones, antibodies, enzymes, you name it.
So red is for all things chemistry.
Essentially, yes.
Uh,
The red top tube, with its simplicity and elegance,
Yeah.
allows us to analyze a wide range of biomarkers, painting a detailed picture of a patient's overall health.
Okay, 2 colors down, a whole
Mhm.
rainbow to go. What's next in our laboratory adventure?
Next up is a tube that sounds like a delicious dessert.
Okay.
The gold top tube,
What?
also known as the serum separator tube, SST.
SST, is that like a supersonic jet for blood?
Not quite, but it is a marvel of engineering.
Oh.
This tube contains a special gel that sits at the bottom.
Okay.
After the blood clots and the sample is spun in a centrifuge, this gel migrates upward, forming a barrier between the clot and the serum.
So it's like a built-in strainer,
Exactly.
keeping the serum nice and clean.
This gel is inert, meaning it doesn't react with the blood, but it's carefully calibrated to create a perfect separation,
Oh.
preventing any further interaction between the clot and the serum.
Why is that separation so important? I mean, can't they analyze the serum even if it's touching the clot?
It's all about preserving the integrity of the serum,
Right.
even after the blood is drawn. Those red blood cells can continue to consume glucose or release potassium,
Right.
which can interfere with certain measurements.
Ah, so the gel acts like a bodyguard, protecting the serum from those meddling red blood cells.
A very apt analogy. This protection is crucial for accurate results, especially for delicate analytes like hormones, lipids, or enzymes, which can be easily affected by even slight changes in the sample.
So the gold tube is all about precision, ensuring that we're getting the most accurate picture of those crucial biomarkers.
Precisely. And it's not just about accuracy.
Okay.
This separation also enhances the stability of the serum, allowing for longer storage and more efficient testing, which is particularly beneficial for large-scale studies and automated labs.
Okay, I'm sensing a theme here. Each tube is like a specialized tool, carefully designed for a specific purpose.
You're absolutely right. And that brings us to our next color, green, the color of urgency.
Green, I'm getting ER vibes already.
You're right on the mark. The green top tube contains heparin, an anticoagulant that acts immediately, preventing clotting from the get-go.
So no waiting around for the blood to clot.
None at all.
Wow.
This is about speed.
Okay.
Getting those critical results as fast as possible. Think electrolytes, blood gases, the parameters we need to know instantly in emergency situations.
So the green tube is the superhero of the ER, providing rapid results that can guide life-saving decisions.
It truly is. But it's not just about speed. Heparin also helps to preserve the blood in a way that allows us to measure certain things that wouldn't be possible if we waited for the blood to clot.
It's like getting a snapshot of the blood in its most natural state before those clotting factors get to work.
While it's not suitable for all tests,
Right.
the green top tube has revolutionized how we handle critical care, allowing for quicker diagnoses and faster interventions.
All right, we've covered blue, red, gold, and green. What color comes next in our laboratory rainbow?
Next, we have lavender, a color often associated with calmness and serenity. And in the lab, it's the go-to tube for hematology, the study of blood cells.
Lavender. That seems like a rather gentle color for something as complex as blood cells.
Don't let the color fool you. This tube is packed with power.
Okay.
It contains EDTA, another anticoagulant, but its mission is to preserve the shape and structure of blood cells.
Why is that so important? Can't you just count the cells regardless of their shape?
It's not just about counting, it's about understanding. Imagine trying to identify different types of cars if they were all crushed into cubes. You'd lose a lot of valuable information.
Got it. We need to see those cells in their natural glory to understand what's going on.
Exactly. The complete blood count, or CBC,
Uh-huh.
one of the most common blood tests,
Okay.
relies on this tube. EDTA ensures that the red blood cells, white blood cells, and platelets are all perfectly preserved for analysis.
So lavender is all about the cells, the building blocks of our blood.
Precisely. And beyond the CBC, the lavender tube is used in hematology, transfusion medicine, even genetic research,
Wow.
because it provides a stable environment for studying these crucial cells.
We are really cruising through these colors. Next up is gray, a color that doesn't exactly scream excitement.
The gray top tube might remind you of something a bit dull.
Okay.
But in the lab, it's all about precision,
Okay.
particularly when it comes to measuring glucose.
Glucose, like blood sugar.
Exactly. This tube is specially designed to prevent changes in glucose levels after the blood is drawn.
Hmm.
It contains a mixture of sodium fluoride and potassium oxalate.
Fluoride. Like what's in toothpaste?
Right.
What's it doing in a blood tube?
It serves a different purpose here.
Okay.
Fluoride inhibits a process called glycolysis, which is how cells break down glucose for energy.
Uh,
Essentially, it puts a halt to the glucose metabolism that would normally continue even after the blood is drawn.
so it's like putting a do not disturb sign on the glucose, making sure we get an accurate reading.
A perfect analogy. This is crucial because
Yeah.
those red blood cells, even after they're out of the body, can continue to consume glucose,
Uh-huh.
which would artificially lower the measured levels.
So the gray tube is like a time capsule, capturing the exact glucose level at the moment of blood draw.
That makes it indispensable for diagnosing diabetes, monitoring blood sugar in critical care settings, and understanding how our bodies process glucose.
Okay, gray is not so dull after all. It's the unsung hero of metabolic testing.
Absolutely. It highlights a fundamental principle of laboratory medicine, controlling the variables to get to the truth.
Right.
Each tube is designed to prevent specific changes that would skew our measurements, ensuring that the data we use to make diagnoses and guide treatments is as accurate as possible.
This is fascinating. It's like a delicate dance between science and precision,
Yeah.
all happening inside these tiny, colorful tubes.
You've got it. And we're not done yet. We still have a few more colors to explore in our laboratory rainbow.
I can't wait to see what other secrets these tubes hold. But before we continue, I think our listeners could use a moment to process all this amazing information.
Actually, we're going to keep going. No need to pause our journey just yet.
You're right. Why wait? Let's continue our colorful exploration of these remarkable tubes and the vital role they play in understanding our health. Okay, so we've explored quite a few colors already, but we're not done with our rainbow yet. Next up is pink.
Pink, while similar to lavender with its EDTA, serves a very specific purpose: transfusion medicine.
Transfusion medicine, that sounds pretty high stakes.
It is. That's why the pink tube has special protocols and labeling to ensure absolute accuracy. Mistakes are simply not an option when dealing with blood transfusions.
No room for error when someone's life is on the line. So what exactly does this pink tube help us do?
The pink tube is crucial for accurately identifying blood groups, Rh types, and even screening for any unexpected antibodies that could cause a dangerous reaction during a transfusion.
So it's like having a safety net, making sure that every drop of blood is compatible and safe for the recipient.
Precisely. It highlights how seemingly small details like color coding and specific protocols can have a massive impact on patient safety.
Okay, onto the final color in our lab palette. Royal blue. It definitely sounds regal.
Royal blue rules the realm of trace elements.
Trace elements, though, sound pretty small.
They are, but they play a huge role in our health. Think heavy metals like lead or mercury, or essential minerals like zinc and copper.
So why does royal blue get the honor of measuring these elements?
It's all about preventing contamination. The royal blue tube is designed to be trace element free, meaning no stray metals can sneak in and mess up our readings.
This is like a super clean room for those delicate measurements.
Exactly. We're often talking about minuscule amounts of these elements, so even the tiniest contamination could skew the results.
This tube must have been a game changer for things like measuring lead levels in children, right?
Absolutely. The royal blue tube allowed for accurate lead testing, which led to policies that protected children from this harmful heavy metal. It also revolutionized how we measure essential minerals and assess exposure to environmental elements.
It's amazing to see how each of these tubes has its own superpower.
Indeed. They are all essential tools for ensuring the accuracy of laboratory testing, which ultimately translates to better patient care.
So we've now explored the whole rainbow of lab tubes. What an incredible journey.
And as you can see, these tubes are much more than just colorful containers. They're vital tools that allow us to delve into the intricate world of blood and unlock the secrets it holds.
Speaking of secrets, we've talked a lot about how these tubes ensure accurate results. But what happens when the wrong tube is used? Could it really make that much of a difference?
It absolutely can. Using the wrong tube can lead to inaccurate results and potentially misdiagnosis, which could have serious consequences for patient care. Imagine a scenario where a doctor suspects a patient has anemia.
Anemia, that's when you don't have enough red blood cells.
Right. Exactly. They'd need a CBC, which means a lavender top tube with EDTA, to preserve cell structure. But let's say the lab mistakenly uses a green top tube, the one with heparin.
The one for emergencies.
Yes. But remember, heparin doesn't preserve cell structure in the same way EDTA does. Over time, those red blood cells might start to change shape.
So instead of getting a clear picture of the red blood cells, it's like looking through a distorted lens.
Precisely. And that distortion could lead to misinterpretations. The lab might see abnormally shaped cells and think there's a problem when it's just an artifact of using the wrong tube.
That's a little unsettling. So a simple tube swap could lead to a misdiagnosis.
It's a stark reminder that every detail matters in laboratory medicine. Every tube has a specific purpose, and using the correct one is crucial for obtaining accurate and reliable results.
Let's take another example. Say a patient is about to undergo surgery and needs a coagulation test.
That would require a pale blue tube with citrate to prevent clotting. But imagine the lab accidentally uses a red top tube, the one that allows clotting.
Wouldn't that be a problem?
Absolutely. By the time the sample gets to the lab, the clotting factors would have already done their job. We wouldn't be able to accurately measure their activity, which could have serious implications for the patient's safety during surgery.
It's like trying to solve a mystery after the evidence has been tampered with.
Exactly. The results would be meaningless.
Okay, so using the wrong tube can definitely lead to inaccurate results. But could it also impact the treatment a patient receives?
Absolutely. Let's look at a scenario where a patient comes to the emergency room with symptoms suggestive of a heart attack.
That's a situation where every second counts.
Exactly. The doctor might order a test to measure troponin levels, which are proteins released into the blood when the heart muscle is damaged.
So it's a key indicator of a heart attack.
Mm.
And they would need results quickly, right?
Absolutely. In this case, you'd use a green top tube with heparin allowing for immediate analysis, but let's say they use a red top tube by mistake.
The one that lets the blood clot naturally. What would happen then?
Then we have to wait for the blood to clot, which takes precious time. Minutes that could mean the difference between getting the patient life-saving treatment quickly or having them experience further damage to their heart muscle.
So a simple tube mix-up isn't just about numbers being off. It can have very real consequences for a patient's health and well-being.
Precisely. And this is especially true when dealing with time-sensitive conditions like heart attacks, strokes, or severe infections.
Okay, so we've established that using the right tube is crucial. But let's say the right tube is used and we get accurate results. Could there still be other factors that might affect the interpretation of those results?
That's a great question. While these tubes are designed to minimize variability, there are still other factors that can influence test results.
Like what?
Well, for one, there's biological variation.
No.
Every individual is unique, and even within the same person, blood values can fluctuate throughout the day due to factors like diet, exercise, stress, or medication.
So even with a perfectly collected and analyzed sample, there's still a degree of inherent variability in our blood.
Exactly. It's like trying to hit a moving target. That's why doctors don't rely on a single blood test to make a diagnosis. They consider the patient's medical history, physical examination, and other relevant factors to interpret those results within a broader context.
That makes sense. It's not just about the numbers, it's about seeing the whole picture. Are there other things that could influence blood test results?
There are. Sometimes medications or supplements can interfere with certain tests, either by directly affecting the analyte being measured or by altering the way the test itself works.
So if you're taking a certain medication, it could throw off the results of a blood test.
It's possible. That's why it's essential to tell your doctor about all the medications and supplements you're taking, even over-the-counter ones, before getting blood work done. This allows them to interpret the results accurately and avoid unnecessary concern or misdiagnosis.
It's a good reminder that communication is key in healthcare. We need to be open and honest with our doctors to ensure we're getting the best possible care.
Absolutely. And it highlights the importance of the human element in laboratory medicine. It's not just about the technology and the tubes, it's about the skilled professionals who draw our blood, process the samples, and interpret the results. They are all integral parts of this complex puzzle that helps us understand our health.
So behind every blood test, there's a team of experts working to ensure those results are accurate and meaningful. It's reassuring to know there are dedicated individuals behind the scenes ensuring quality and precision every step of the way.
Precisely. From the phlebotomist who skillfully draws your blood to the lab technician who analyzes the sample, each person plays a vital role in this intricate process.
Okay, I'm starting to realize that these tubes are really just the tip of the iceberg when it comes to the world of blood testing.
You're absolutely right. These tubes, with their color-coded caps and specialized additives, are the unsung heroes of laboratory medicine. But they are just one piece of a much larger and more complex puzzle.
It's like a symphony of science and technology, all orchestrated to help us understand the intricate workings of our bodies.
A beautiful analogy. And as we delve deeper into this symphony, we discover the incredible precision, expertise, and dedication that go into every blood test.
So the next time I get blood drawn, I'm definitely going to look at those colorful tubes with a newfound appreciation. They're not just containers, they're gateways to a world of information about our health.
I encourage everyone to do the same. Ask questions, be curious, and don't be afraid to learn more about what goes on behind the scenes.
Knowledge is power, and in the world of healthcare, that power can truly make a difference. But before we wrap up this fascinating exploration of blood testing, there's one more question I'd like to explore. We've talked about how these tubes revolutionized laboratory medicine, but what about the future? Are there new technologies on the horizon that might change the game again?
That's a great question. The field of laboratory medicine is constantly evolving, and while these color-coded tubes are still the gold standard, we are seeing advancements that could change how we collect and analyze blood in the future.
That sounds exciting. Can you give us a sneak peek into the future of blood testing? What's brewing in the world of lab medicine?
One exciting area is dried blood spot testing. Imagine a world where you could prick your finger, put a few drops of blood on a special card, and mail it to a lab for analysis.
No more needles and vials. Sign me up. That sounds incredibly convenient.
It's still early days, but this technology has the potential to make blood testing more accessible and convenient, especially for monitoring chronic conditions.
That would be a game changer for so many people. What else is on the horizon?
Another fascinating development is something called lab-on-a-chip technology.
Lab on a chip. That sounds futuristic.
It is. It involves miniaturizing lab processes onto tiny chips, allowing for faster and more portable testing.
So it's like shrinking a whole lab down to the size of a credit card.
Exactly. And this could have huge implications, particularly in point-of-care testing. Imagine a doctor being able to run a full panel of blood tests right there in their office, getting results in minutes.
Wow, that would revolutionize healthcare. No more waiting days for lab results.
Precisely. And while these technologies are still under development, they highlight the constant innovation happening in laboratory medicine.
It's exciting to think about the possibilities. But even as these new methods emerge,
The fundamental principles of accuracy, reliability, and precision will remain paramount.
so even in a future with finger prick tests and lab-on-a-chip devices, we'll still need to make sure those results are accurate and reliable.
Absolutely. And that brings us to the human element, which remains crucial in any medical testing scenario.
The people who make sure those tests are performed and interpreted correctly.
Exactly. The phlebotomists who skillfully draw our blood, the lab technicians who process the samples, the hematologists and pathologists who interpret the results, they are all part of this intricate chain of trust.
It's a team effort, ensuring that from the moment that needle goes in to the moment the doctor gives us the results, everything is handled with care and expertise.
Precisely. These professionals undergo rigorous training, follow strict protocols, and participate in continuous quality assurance programs to ensure the highest standards of accuracy.
It's reassuring to know that there are dedicated experts working behind the scenes to make sure those test results are reliable.
And that's ultimately what it's all about. Using these tools, these color-coded tubes, and the expertise of laboratory professionals to gain insights into our health-guiding decisions that can improve our lives.
Wow, we've really gone deep today. From the history of those colorful tubes to the potential future of blood testing, it's been a fascinating journey.
And I hope it's given you a newfound appreciation for the complexity and precision that goes into every blood test.
It definitely has. So the next time you see those tubes, remember that they're not just containers. They're time capsules, snapshots, and even guardians of our health. They represent a silent symphony of science, technology, and human expertise, all working together to unlock the secrets hidden within our blood.
And as we move forward, let's continue to be curious, ask questions, and understand the why behind our healthcare.
Because knowledge is power. And in the world of healthcare, that power can truly make a difference.